Hello student, in previous video we see about the different methods of classification of element. First is the Dobereiner triads and second is the Newland's law of Page. Then third is the Mendeleev's periodic table, and today we discuss about the modern periodic law. Before starting our topic, if you like my video, then please like, share and subscribe to my channel. My channel name is Sharda Surose. So now we start our topic, that is the modern periodic table. So in previous video we see about the Dobereiner triads. Dobereiner triads give one postulate. This postulate is common in all the theories. Like the Dobereiner triads, then Newland's law of octaves, and then Mendeleev's periodic law. That is the properties of elements are the periodic functions of their atomic mass number. Means all the scientists make the arrangement of periodic table according to the atomic mass number of an element, and according to that atomic mass number of element, the arrangement in a particular position in the table they make. Okay, but modern periodic law is very different, because according to modern periodic law, the properties of an elements are the periodic functions of their atomic number. Okay, means the properties of an elements are the periodic functions of their atomic number, because in previous theories that time the internal structure of an element is not known. Okay, but in the year of 1913, the English scientist in the year of 1913, the English scientist Henry Moseley discovered the internal structure of an atom, and according to his discovery, he said that there are some electrons are present in the atom. They are present in different shells of an atom, and in the nucleus of an atom, protons and neutrons are present. And atomic mass number, it is nothing but the addition of protons and neutrons. It is called atomic mass number. But atomic number, it is only the number of electrons or number of protons, दोनों में से एक, out of two, any one number of protons or number of neutrons present in an element, it is called as the atomic mass number. And according to his discovery, he said that the properties of an element are the periodic functions of their atomic number, not atomic mass number. Hence, the properties of an element, every element shows the different property, and their property depends on their atomic number. Basically, atomic number, it is nothing but, suppose this is the structure of an atom. So this is the nucleus of an atom, and this is the different shells are present around the atom. So in the nucleus, the protons and neutrons are present. Proton, it is the positively charged particle. Neutron, it is the neutral, means no any charge present on the neutron particle. And here, so it is indicated small here, and here these are the different orbits are present in the nucleus. In that different orbits, there are electrons are present. They are revolving around the nucleus of an atom, and it is called as the electrons. It is the negatively charged particle. So atomic number means the number of electrons or number of protons. It is called as the atomic number. Both are same, because the electrons are negatively charged particle and protons are positively charged particle. They both are balanced to each other, hence their number is the same. So we can take any number, that is the number of electrons or number of protons, it is called as the atomic number. And in modern periodic law, the statement was given, that is the properties of elements are the periodic functions of their atomic number, not atomic mass number. And hence, because the properties of an element it described or predicted very accurately with the help of atomic number. Hence, it is also called as the modern periodic table. It is also called as the long form of periodic table. Okay, one question may be asked in exam. Why modern periodic table it is called as the long form of periodic table? Because modern periodic tables say that the properties of an elements are the periodic functions of their atomic number, and atomic number gives the more accurately property of that particular element as compared to the atomic mass number. Hence it is called as the long form of periodic table. And means after that the modern periodic table is classification of modern periodic table was given, and according to that the structure of a modern periodic table is very different, that is available nowadays, because today there are 118 elements are known to us, and their properties of every element is different, their electronic configuration is different, and their properties also different, their structure is also different, and this according to their structure, property, and different their nature, according to that the classification of periodic table is given, and this is called as the modern periodic table. And in today's lecture we also see about the structure of modern periodic table. This is about the modern periodic law. In modern periodic law only one statement is very important, that is the properties of an elements are the periodic functions of their atomic number, not atomic mass number. Okay, is it clear? So next point is our the structure of modern periodic table. Okay. The structure of modern periodic table consists of basically 4 blocks, that is the S block, P block, D block and F block. This classification of elements or this classification of blocks is given according to their properties of an elements. Basically in modern periodic table 18 columns are present, and these 18 columns it is called as the groups. Okay, and there are 7 periods are present. These 7 periods is called rows. Okay, rows. So how many groups are present? 18 groups are present. So 18 groups means how many? 18 columns are present. It is called as the groups, and 7 rows are present. Rows are present. It is called the means 7 rows are present. It is called as the periods. Is it called as the periods, and 18 columns are present. 18 columns are present called as the groups, and according to those groups and periods they make a box. Okay, so there are 118 boxes are present in the periodic table because they fitted. In that boxes the 118 elements are fitted into that table, and according to apart from these 7 periods, the 2 periods are present at the bottom of the periodic table. Okay, they start from the means first series or first period start from the lanthanum elements, so it is called as the lanthanides, and second is start from actinide, so it is actinium, so it is called as the actinides, because at the bottom of the periodic table the 2 periods are present. This is a part of these 7 periods. This is the part of these 7 periods, but they shows the different property, hence their position is given at the bottom of the periodic table. So now I draw here the periodic table and how they are classified, because the S block element having the different groups are present, in D block also different groups are present, in P block also different groups are present. Why there are different and different groups are present? Because they shows the different and different property. Also their atomic number is also different, their atomic mass number is also different. So there are 18 columns are present, so it is called as the groups. So now I draw here 18 columns. One column is there, 2, 3, 4, 5, 6, 7, 8. Okay, so these are the 18 groups are present in the periodic table. Here the position of hydrogen, this is the position of helium. Then 1 2 3 4 5 6 and 7 periods are there. 1 2 3 4 5 6 7. Okay, one is extra, so I wrote this. Here not H, helium, He. Okay, so after that first, second, so from group means group number first and second, it is called as the S block element. So group number third 3 to group number 12, it is called as the D block element. So 3 start from here, 3 4 5 6 7 8 9 10 11 12 13. Okay, up to the 13, up to the 3 to up to the 12, it is called as the D block element. And group number 13 to 18, 15 16 17 18, it is called as the P block element. And at the bottom of the periodic table, so this is also the part of 7 periods, but their properties are different, so their position is mentioned at the bottom of the periodic table, and this is called as the F block elements. These are the F block element. Up to from the group number 3 to 12, it is called as the D block element. Group number 1 and 2, it is called as the S block element. And group number 13 to group number 18, it is called as the P block element. Okay, P block element. So how many periods are there? 7. 1 2 3 4 5 6 7. So F block elements, it is also the part of these 7 periods, but there they shows the different property, hence they are present at the bottom of the periodic table. So in that totally 28 elements are present in F block elements. So 1 2 3 4 6 7 8 9 10. Means I make here the 14 squares or 14 blocks, because here the lanthanum is present and here the actinium is present, but these both elements are the part of the D block element, but it starts from this lanthanum and actinium, so it is called as the lanthanide series and it is called as the actinide series, but both lanthanum and actinium both are the D block elements. But its F block element is start from this element, so it is mentioned in the F block, but their electronic configuration is like the D block elements. So here lithium, sodium, potassium. Okay, after that different elements are there. Then here beryllium, magnesium, calcium. There are also different groups are present. So here the 13 groups there are having a boron family, boron, aluminium, gallium. So here after that boron, the atomic number of boron is what? 1 2 3 4 5, then 6, then carbon, silicon. After that silicon, germanium is there. Okay, after that carbon there is a nitrogen family, nitrogen, Australia, New Zealand, means the group is like that. Antimony. After that nitrogen there is oxygen family, cerium, thallium. Then after that fluorine, chlorine, bromine and iodine, halogen family is present. Then helium, neon, argon, krypton, xenon and radon. Means these are the noble gases are present. So this is in D block elements also the 4 periods are present. The first series it is called means the D1 series, D2 series, D3 series and D4 series. In D block element 4 series are present there. So it starts from scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. This is the first series. After that, second 2D, 3D and 4D series are present. So, and this is one zigzag line is present in the P block element. This zigzag line gives some very important properties of elements. Means basically the S block elements, there is the metals are present. In P block elements basically means more elements are non-metals are present. In D block elements the metals are present, but it is called as the transition element or transition metals are present in D block element. And here the 14 means here also 14 and second series of A block 14 elements are present. Lanthanum and actinium it is the part of D block elements. Okay, so it starts from the lanthanum and end at the lawrencium. Okay, and sorry, not lawrencium, lutetium, and the second A block series start from actinium and end at the lawrencium elements. Okay, so this is the whole structure of modern periodic table. So in P block elements one zigzag line is present, and this zigzag line is also shows a very important property of an element. So above this zigzag line, that is the boron, silicon, arsenic, tellurium, means the metalloids are present. Metalloids means they show the some property of metal and they show the some properties of non-metals. Basically semiconductor are present. So above this zigzag line, the means the silicon, arsenic, these are the semiconductor properties, that is the metalloids property of an element represent. And below of this, that is the aluminium, germanium, shows the property of metal, like the metal. So this zigzag line is also important because it also gives some property of an element. So this is the whole structure of modern periodic table. Okay, so in today's lecture we stop here. In next lecture we learn about the electronic configuration of different elements in the periodic table. So we know that basically in the periodic table 118 elements are present. Every element shows the different electronic configuration. So this topic we see in the next period. So today we stop here. Thank you.